Let us now proceed to property B. So if U is in V and C is a real number, then C times vector U is in V. So since our V is Rn, so we will let U be this matrix be in Rn, and also we will let C be in R. Okay. Then you have to show that C times U is in V. So we start with this one. Then C times U is equal to, again, this operation. Okay, so ito na operation is just the um, multiplication of the matrix by a scalar. Alright, so that is just scalar times a matrix. So by definition, that is just equal to C times U1, C times U2 up to C times UN, and this is in Rn because multiplication of real numbers is close. Kasi nga, bawat isa nito, so ito, no, C times U1, oops, itong C times U1, C times U2, and C times UN. These are mga real numbers. And so, since each are element of real numbers, it is an element of Rn. So we have that property. Okay, so to show property number 5, we pick here U and V, arbitrary elements, no? Kasi nga for each ito, we pick an arbitrary element of V and we pick an arbitrary C in R. Okay, so and then we show this property here. Okay, so property number 5. Okay, so property number 5. Alright, so again, let us pick two members of V. Okay, so in this case, we pick vector U and vector V in Rn. And let C also an element of R. Then C times U plus V is equal to, this is equal to, so converting this one to scalar multiplication in matrix, and again, this operation, okay, this particular operation will be converted now to the usual addition of matrix. Again, ito magkaiba itong dalawa, no? This is addition of matrix. This is for the vector. And this one is, this operation is the scalar multiplication of matrix. Okay, so continuing that, this one, so we have to operate first on the parentheses. So this is addition of matrix. So just add corresponding entries. So U1 plus V1, U2 plus V2 up to UN plus Vn. So this one becomes this matrix, and then scalar multiplication by matrix. So we have C times the entries, no, of the matrix. So you have C times U1 plus V1 up to C times UN plus Vn. So again, C here is just a real number, so distributive property holds over this one. So you just have C times U1 plus C times V1 up to C times UN plus C times Vn. We can rewrite this one using this one, sum two matrices, no? You can verify that kasi kung i-add mo ito ulit, the result will be this one, right? And again, you can rewrite this one by scalar multiplication, C times this matrix plus C times this matrix. Again, you can verify, no? Ito siya ang product niyan, ito, right? And then, we know that this matrix is just a vector u. So we can convert this one to c times vector u. And then this one is vector addition, c times vector v by definition of its operation. Hence, we have shown this property. Okay, so that's property number 5. We now show property number 6. In this case, we pick um, any vector in V and any real number C and D in the set of real numbers. Then, okay, so we start from here. Okay, so in this case, you have C plus D times the vector U. Again, this operation is scalar multiplication of matrix, so that is why it's converted to this one here. Okay, then you have scalar multiplication. You multiply C plus D to the entries of this matrix. You have this one, and then distributive property again because yung mga laman ng matrix na ito ay mga real numbers lang naman. So distributive property holds. You have this one. You can split this matrix into two so that we have this one, and then again similar procedure. So you extract C from here times that matrix, D times that matrix, and again this is the vector U times C times the vector U, and this one is plus vector addition D times the vector U. That shows the property number 6. Okay, so property number 6 is checked. We are down to the last two properties. Okay, so again, we pick an arbitrary u in V and any real number. Again, we pick any real number C and D here. So let us have U and U, C, and D. Okay, so let U be this matrix in Rn and C and D be real numbers. Then we will start from here. Okay, so that is C times the quantity D times U. Alright, so this is equal to, we will convert this to matrix. Again, this is matrix multiplication. So C times, this is, again, this is scalar multiplication of matrix. So D, no? D times the vector U or matrix U. So U1 up to UN. Again, that is equal to, so this is equal to C times, we will operate this first. Okay, so that is DU1 up to DUN. This is equal to, again, scalar multiplication of matrix. You have C times DU1 up to C times DUN. Alright, so again, these are real numbers. So again, the associative property holds in that entries. So you just can write this one as C times D times U1 up to C times D times U sub N. So we can rewrite this one as, extract na naman natin ulit si C times D, alright, times UN. So U1 to UN. Convert this one to vector operations. This one is just CD times the vector, and And I think yan yung gusto nating mangyari dito, no? This one here. CD times the vector U. Okay, so therefore, you have this equation. You have this equation here. And we are now down to the last property. So property number 8. This is now for any, right? So for any vector u in V. So basta may for any tayo, let us start the proof, no, by picking any talaga, any vector in the set. In this case, you have this one. This is just in Rn. Alright, so and then what happens kapag nag-multiply tayo? Again, we are going to show this one. So mag-start tayo dito, no? Yan, start tayo dito. So that will become 1. This is just a real number 1. 1 times the vector u. So converting this to matrix, so scalar multiplication lang tayo ng matrix. So u1 up to u sub n, and this is equal to, okay, 1 times u1 up to 1 times un. This is equal to, again, these entries are real numbers, and we know that this particular one here in the set of real numbers is the multiplicative identity. Ibig sabihin, lahat ng number na imumultiply mo sa 1 ay magre-resulta sa number na yan, right? So in the set of real numbers, for all x in the set of real numbers, okay, 1 times x is equal to x times, and that is for all, for all x. And so that will become u1 up to un, and this is just the vector u. Okay, so we have shown that it is equal to u. So number 8, our number 8 here is already done. Okay, so we are done with number 8. Therefore, the set Rn together with this operation is a vector space.